So today we are going to start the second part, that is lecture 2 of wave optics, that is BSc 4th sem. Second lecture. In the first lecture we have seen part of unit 3, that is waves and theories of light. We discussed about wavefront and properties, construction, and also Huygens principle of secondary waves. So in today's class, that is lecture 2, waves and optics, and particularly we will be discussing about interference of light. So on the screen, so you see on the left hand side, there is the physicist Thomas Young. So Young's experiment is the one that you are seeing in the middle, that is, which clearly gives us about the interference phenomena, that is constructive and destructive interference phenomena, which we are going to see. He is the Thomas Young physicist. On the right hand side, we are seeing another scientist. He is Augustin Fresnel. So we will be seeing in the later part of this lecture about biprism, that is Fresnel's biprism is constructed by Augustin Fresnel. So we have seen that in the previous slide that BSc 4th sem waves and optics, we have 6 units, and third unit, so we have discussed about wave optics, and in fourth unit we discussed about interference. And in interference, so we have seen about what we are going to see today is division of amplitude, division of wavefront. So these parts we have discussed earlier from wave optics, unit 3, electromagnetic theory of light, wavefront, construction, properties, types, Huygens principle of secondary waves. This is what we have discussed earlier. Also we have introduced to interference, which we will be continuing in today's class. So we will discuss about division of amplitude and division of wavefront, and division of wavefront we will be particularly studying in detail about Young's double slit experiment, the theory. There is a derivation for this, a simple derivation, and then some analytical treatment, and followed by the Fresnel's biprism and Lloyd's mirror. So in the subsequent classes we will be seeing about division of amplitude, wherein we will study about thin film interference, and air wedge, and also Newton's rings. So as we have seen yesterday, interference, we tried to understand that when two light waves of same frequency and equal or nearly equal amplitude traveling in same direction, they overlap or superpose, then there will be redistribution of light intensity in the region of overlapping. In the region of overlapping, the intensity is distributed. That is, in some part is dark and some other part is bright. Intensity missing at the dark part appears at the gets added at the brighter region. So the superposition of principle states that when two or more waves arrive at a point simultaneously, each wave produces its own displacement at that point as if the other waves are not present, and the hence resultant displacement is equal to the algebraic sum of the individual displacement. So you see here, this is what we have discussed yesterday. So a crest falling on crest, a trough falling on trough, that is, if its displacement is y1, the other displacement is y2, resultant is y is equal to y1 plus y2. It is a addition of addition of amplitudes, addition of displacements, and that is the constructive interference. And the other diagram we see that crust and trough, a crust and trough, this is plus a, this is minus a, there is a vector sum, so the amplitude gets cancelled and it is minimum intensity, it is destructive interference. So same we have seen in this diagram. So when a crust and crust or trough and trough fall, there is addition in the respective side, plus minus. So this is constructive interference. So if there is a crossover of crust and trough, then the intensity gets cancelled and it becomes 0. If a crust of one falls on crust of other, or trough of one falls on trough of other, the amplitudes are get added, resultant amplitude increases, hence intensity increases, that is the constructive interference. If the crust of one falls on trough of other and then resultant amplitude decreases, this is decrease in intensity, destructive interference. Then in all, we understand interference as physical effect produced as a result of superposition of light waves in interference. Physical effect is because of interference. As a result of interference, we see a set of pattern that is alternately bright and dark bands. It is a physical effect which you can see because of interference. Thus, interference of light is modification in intensity of light in the region of overlapping of two or more beams of light. This is in accordance with law of conservation of energy. So according to conservation of energy, total energy should remain same. If one particular part, because of destructive interference appearing, is less intense or dark, that energy lost appears at bright or constructive interference part, so that total energy remains same. Hence conservation of energy is valid in case of interference. So this is what you can write for interference. Then for interference we need two waves or two sources, and the two sources condition is that the two sources must be coherent. Coherent sources, what is coherence, or what do we understand by coherent sources? If you have two sources which are identical properties, that is they should have same wavelength, if they have same frequency and same amplitude, and they must be having same phase or constant phase difference, then such sources are called coherent sources of light. Condition is the two sources of light must emit waves of same wavelength, same frequency, same amplitude, and the phase must be same or a constant phase difference between them. And it is in practice, two independent sources of light cannot be identical. So we cannot get two such sources in directly in the market. We cannot buy two coherent sources. Therefore, but for interference we need coherent sources. Therefore, coherent sources are derived or they are obtained by two methods. Indirectly we get two coherent sources by two methods. One is division of wavefront, which we are seeing first, and other is division of amplitude. That is, we divide the wavefront into two parts because the two parts are of the same original wavefront. Therefore, the two beams or two parts of the same wavefront will be sending beams according to Huygens principle of secondary waves. Every point on the wavefront is a source of new wave. So, 2 points if we take from the wavefront, which is divided into division of wavefront into two parts, then these two beams will be identical. They will have same frequency, same color, same amplitude, or constant phase difference, or same phase. So these indirectly, either by division of amplitude or by division of wavefront, so we can get two sources. And there are two types of coherences. So one is called temporal coherence, another is spatial coherence. Just mention these two. temporal coherence means the coherent source. If a light sends the source, up to what extent in lengthwise, longitudinally, it is coherent. So beam is going without dispersing. Spatial means it is lateral in the space. If there is coherence, up to what extent? So it is spatial is lateral, temporal is along lengthwise. So these two, to just mention these names. Now, to get a stable interference, see, these are the conditions. So what are the conditions for steady interference of light? So first, to get interference, two sources must be coherent. That is, the two sources which are interfering. So what we have said is two waves overlap and produce interference pattern. If a crest falls on crest or trough falls on trough, it is constructive. If a crest and trough cross, then it is destructive. So what we need is two sources, and those two sources, how they should be? The two sources should be identical. So they should be coherent sources. It means they should have same frequency, same wavelength, same amplitude, same phase or constant phase difference. So we also know that we cannot buy two separate sources which are identical. Therefore, we obtain two beams from indirect method, that is experimentally we obtain. So the two experiments are, one is division of wavefront, the other one is division of amplitude. So under division of wavefront, we will see first Young's double slit experiment. So before studying Young's double slit experiment, we will try to understand what are the conditions to get a steady interference pattern. That is, we need to have two sources of light which should be coherent. They should have same color, same frequency, same amplitude, and the two sources should be monochromatic. Once again, monochromatic means single color means single wavelength. So they should have same wavelength, and the amplitudes of the two waves must be same, and two sources must be narrow. There should not be wide sources. So we can make the sources narrow by putting a fine slit in front of the source. So we can put a fine slit in front of the source, we get a beam, narrow beam from that, and that can be used as a source for steady interference pattern. Separation between the two slits. So from one slit, we divide into two parts. The separation between the two slits, from which again two light beams are going out, which we will see in the next experiment, this distance must also be very small. That is, separation between two sources should be small, which is represented by small d, and distance d between source and a screen on which we are seeing the pattern, it must be large. So putting all these conditions, so two sources should be coherent, they should have same color, and amplitudes must be same, two sources must be narrow, the separation between the two sources must be small, and capital D must be large. And the two methods that we mentioned for producing coherent sources are division of wavefront. Incident wavefront is divided into two parts, either by reflection, refraction or diffraction. These two parts of same wavefront travel unequal distance and they reunite and at some angle, and they produce interference pattern. So basic principle of division of wavefront is the incident wavefront, that is wavefront from the original source, it is divided into two parts. According to Huygens principle, every part on the wavefront is a new source. These two beams are taken, they travel unequal distance and they overlap, they reunite at some particular angle and produce interference fringes. So depending on whether there is crest falling on crest or trough falling on trough, either it will be bright or dark. The experiments that we are going to study under division of wavefront are examples, Young's double slit experiment, which we will see now. After that, we will have Fresnel's biprism and Lloyd's mirror. Young's double slit, Fresnel's biprism and Lloyd's mirror. These three experiments are for division of wavefront. And there is one more second branch to get coherent sources is division of amplitude. Amplitude of incident beam is divided into two parts. by reflection or refraction, these divided parts reunite after traversing some distance and they produce interference. So examples are interference due to thin film, air wedge and Newton's rings. That is what we are going to see in this. So now understanding division of wavefront and division of amplitude to get interference by indirect way, getting coherent sources by indirect way. First experiment that we are going to see is Young's double slit experiment. So it is very simple and interesting to know that. So we will try to understand this experiment. So what all we have discussed so far will also be a repetition, but we can put it in systematically. So if you look at the diagram, so first you are seeing this S is a small opening. So because this line limits the source and there is only small opening. I hope you are able to see this small opening. Then a light comes out of this. So it is propagating like this, first semicircle. Then it goes further. This is the next semicircle. And next still further it goes. And this is the wavefront. And when it reaches the next part, so there is one more line, one more partition, one more slit where we have two holes. One is A, another is B. So here is only one. So one wave is coming out. From here it is blocked, and from this part and this part light comes out. So A also is a source of new wave. B is also source of new wave. How? Because this wavefront, every point on the wavefront is a source, and only opening for one is here, another is here, one at A, another at B. So light starts coming out from A in the form of waves in this direction, from B in this direction. These two overlap in this region, overlap, and you know that possibilities are, see, here it's a screen. So we will see first this part E, D, C, F and G. So this point, see, this point is, so you can see this point is bright, this point is dark, this point is bright. So this point is dark, this point is bright. So it means alternatively from center, E is the center of point, from center alternatively dark, bright, alternately dark, bright fringes are produced. This is the physical effect. So what has happened? We will repeat. We have a source S. There is only one point opening. A wave comes out of this. So we call this as wavefront at any instant of time. So it propagates up to this point until it encounters a block, and on this block there are two openings, A, opening B, and because of Huygens principle of secondary waves, this part sends out wave A and from B. So once again a wave from A starts and wave from B starts. So these propagate, they overlap in this region. Now you can see that S is a monochromatic source, A and B are part of S. These two are part of S. Therefore, A and B are identical to S. Therefore, A and B are monochromatic source, coherent source. They produce interference pattern. And you see that this point E is equidistant. This point E is equidistant from A and B. So point E is equidistant from A and B, means light propagating from this point reach E and from this point reach E simultaneously. Therefore, there is a crest falling on crest. So you can see that trough falling on trough, crest falling on crest. So therefore, there is addition of intensity. So it is constructive interference. Therefore, it is a bright point. So you can see that this is a bright, because so this is bright because a crest falling on crest, trough falling on trough, because the light is reaching in phase. So now if you look at this point and this point, so this is a line drawn by all points where a crest is falling on crust, and this is the line which are a trough and crust. Say this is a trough, this is a crust. Trough and crust cross, therefore upper side it is plus a, lower side it is minus a, so intensity gets cancelled, so it is a dark point. So therefore it is destructive interference. So once again this line is drawn, there is a alternately bright and dark. So this point is all points which are connecting the crest falling on crest, that is bright points together gives a bright fringe, crest falling on crest. Here crossing of crest and trough, so therefore it is dark. Similarly here. So in all, so the phenomena of interference division of wavefront is demonstrated by Thomas Young in the year 1801. S is monochromatic source of light. A and B are two slits separated by small distance. Small d is distance between two sources. Capital D is distance between screen and source. According to Huygens principle of secondary waves, every point on the wavefront is a source of new wavefront, that is A and B, and sends secondary waves. They travel and superpose after some time, producing interference. If crest of one falls on crest of other, or trough of one falls on trough of other, there is addition of amplitude resulting in a bright fringe, that is constructive interference. On the other hand, if a crest of one falls on trough of other, then there is cancel of each other, and now, so quickly you review what we have done in Young's double slit experiment. It is based on division of wavefront. There is a source S, which is sending light, and it is blocked by a separator. It's A and B are two pinholes. Again, light travels from these two pinholes, and each A is a source of secondary wave, B is secondary wave, A and B are part of S, therefore they are coherent, and light propagates, and with some time a crest, there is overlapping of waves from A and B, so they superpose, crest falling on crest, trough falling on trough results in constructive interference or bright. Destructive interference is trough and crest cross. So this is Young's double slit experiment, which we will be seeing in detail. Now, a theory, that is, you also know about fringe width beta. So we need to derive an equation, that is equation for fringe width, equation for fringe width beta. So you will be asked, describe Young's double slit experiment with the theory, means it is for full 10 marks. So during that time you need to derive the expression for fringe width, that is theory of interference. Theory of interference fringes, that is derive the expression for fringe width. So same diagram of Young's double slit we will be using. So you can see that we have a source S. So you concentrate on this diagram. So source S, it sends out light and it reaches the A and B, this line A and B. A, from A there is one hole, again light propagates in this direction, B is another opening, and waves start from this A and B, they overlap and produce interference pattern. So again there is a screen. Now the markings are different. C is center, C is equidistant from A and B, which we will be using in the derivation. So C is the center, A and B are equal, C is equidistant from A and B, so therefore C is center, so it will always be bright. And P is any point on the screen which is at a distance x from C. Now you can draw one line Q and from B R. So now distance between A and B is small d, right? Small d is distance between A and B, that is separation between two sources. Now A and B are two sources which are parts of S, and C is center, therefore QC is d by 2, CR is d by 2, half of this, half above, half below, because this distance is d. And now from AB source to screen, the large distance is capital D. So once again I'll repeat, S is a source of monochromatic source, A and B are slits which are equidistant from S. So from here A, from here B are equidistant. A and B act as two coherent sources separated by distance D. Let screen be placed at a distance capital D. The point C is equidistant from A and B. Therefore, path difference of waves reaching C will be 0. Thus, C will always be bright. Now, consider point C. Once I'll show. Consider point P from C. The distance is x. So from here we are starting. Consider point P, which is at a distance x from C. The waves reach P from A and B. So you can see here one wave, AP is one wave, BP is another wave. So which is designated by the path length. Okay, AP, A to P is one beam, B to P is another beam reaching P, and just by looking at this you can make out that AP is smaller, BP is longer. So the path required to travel, path traveled by light to reach from B to P is larger than A to P. So therefore there is a difference in path difference of AP and BP, there is a difference in path. So this is what we are going to calculate by simple mathematical steps. So I will repeat, if you understand this, the rest of the derivation will be very simple. A, P is any point on the screen which is at a distance x from C. A light wave from A to P reaches, another from B to P reaches. So you know that AP is path length, BP is another path length. There is difference between these two paths, that is what we are going to find out. Now, the waves reaching at point P from AB, here PQ is equal to x minus d by 2. See, PQ from P to C is x and Q to C is d by 2. Therefore, PQ is x minus d by 2, and P to R is up to C, it is x, and C to R is d by 2. So it is x plus d by 2. So therefore, PQ is equal to x minus d by 2, PR is equal to x plus d by 2. So now we want the difference between BP and AP. Therefore, we get BP square minus AP square. So BP square minus AP square is, see, we want path difference between BP and AP. So therefore BP square and AP square. So we make two triangles. So first you look at this triangle APQ. APQ is one triangle, then BPR is another triangle. So of this triangle, we know this side is D, this side BP PR is x plus d by 2, PQ is x minus d by 2, but this distance AQ is again d. So using these, so we can write BP square minus AP square is equal to d square into x plus d by 2 square minus AP square is d square plus x minus d by 2 square. So if you understand this equation, so rest is a simplification. So what are BP square minus AP square? I will show you once again. See, AP is this, BP is this. So we have considered the triangle APQ, APQ and BPR. So in this, PR is D, AQ is also D, PQ is x minus d by 2, whereas PR is x plus d by 2. So applying Pythagoras theorem, so we get BP square minus AP square is equal to D square into bracket. So make the difference between capital D and small d. Capital D is larger distance between the screen and the source. Small d is distance between two sources. This is very small. So d square plus x plus d by 2 square minus d square into x minus d square. So if you simplify this, d square goes, so other things cancel. So BP square minus AP square will be 2xd. It is a plus b whole square. So you have to do a plus b whole square. This is a minus b whole square. So afterwards, after simplification, so you get 2xd. So BP square minus AP square is BP minus AP into BP plus AP, which is equal to 2xd. Why we are writing like this is we want this BP minus AP is required. So BP minus AP is equal to 2xd divided by BP plus AP. So you bring this to this side. So BP minus AP is equal to 2xd divided by BP plus AP. But BP is approximately equal to AP, that is equal to capital D. So these are almost same. So therefore BP plus AP is D plus D 2D. Not here, don't put it here, otherwise it will become 0. So no meaning. So only in this bracket we are making approximation, put BP is equal to AP, capital D, so 2D. Therefore, path difference between BP and AP is equal to xd by d, where x is the distance of point P from center, d is small d is distance between two virtual sources, capital D is distance between screen and source. Also, phase difference can be written as 2 pi by lambda. Phase difference can be written as 2 pi by lambda into path difference, that is xd by d. So we can apply. Now once you find the path difference, then whether point P is corresponding to bright or dark band, whether it is constructive or destructive, that can be very easily understood by putting a condition. So this you have to remember always, that for a bright condition, if path difference is integral multiple of lambda, so if it is n times lambda, then P will correspond to a bright fringe or a constructive band. So path difference is what? This one, xd by d. Xd by d, if it is equal to n lambda, you put this condition. If this is satisfied, then P is bright, where n value can take 0, 1, 2, 3, or x is equal to, so you take this on the other side. Now capital D comes to numerator, small d comes to denominator. So x is equal to n lambda by d. This equation gives, so understand this, x is equal to, where x is a position of point P from center, is given by n lambda d by d, where n is integer, lambda is wavelength, capital D is distance between source and screen, small d is distance between two sources. So this equation gives distance of bright fringe from C, because it is equal to n lambda. It corresponds to bright fringe. At C path is 0, it is already a bright fringe. So putting n is equal to 1. So put n equal to 1, it will be x1. First bright fringe is equal to 1 means lambda d by d, n equal to 1. N is equal to 2, second bright fringe, it is x2. So n equal to 2 lambda d by d. Then third x3, 3 lambda d by d. Like this you have infinite number. So xn is equal to n lambda d by d. Therefore, now distance between any two consecutive bright fringes, that is first and the next bright fringe, in between there will be a dark band, that we have to neglect. We have to take the distance between one and the next. Therefore, it is called consecutive. So x2 minus x1. So x2 minus x1 will be 2 lambda d by d minus lambda d by d equal to lambda d by d, or x3 minus x2 also lambda d by d. So whether it is distance between any two bright fringes, so it is lambda d by d. So we are going to close the session briefly. So quickly you see same thing for dark fringe. Only condition is that path difference must be 2n plus 1 lambda by 2. If it is n lambda, it is bright. If it is odd multiple of half wavelength, 2n plus 1 lambda by 2. So therefore, n is equal to 0, n is equal to 0, it is lambda d by 2d. N is equal to n, 2 plus 1, 3 lambda by 2d. So n is equal to 2, 4 plus 1, 5 lambda d by d. Therefore, x2 minus x1 is 5 lambda d by 3 lambda 2d, comes out to be lambda d by d. So therefore, whether it is the distance between two bright or two dark fringes, it is same. Therefore, all the fringes are parallel. And ultimately, the final equation for fringe width is lambda d by d. Fringe width is directly proportional to lambda. So if the color of light is changed, the distance between fringes will change. That is, if lambda increases, fringe width increases. So if the screen is moved away from the source, then also beta increases, and it is inversely proportional to small d, distance between two sources. If the sources are brought together, then beta increases. If d is increased, then beta decreases. So beta is fringe width, and this is a very important equation for fringe width, which will be used for all the three experiments. Same derivation: theory of Young's double slit, theory of biprism, theory of Lloyd's mirror. So again, while discussing next week we will tentatively schedule for next week's. Will be putting the schedule in the group. Otherwise, it will be Friday and Saturday next week. So weekly 2 days, Friday, Saturday, we will take up further discussion on interference. So today what we have seen is, so we started with basic of interference. So we tried to understand interference on the basis of principle of superposition, and when two waves arrive simultaneously at a point, if a crest falls on crest or a trough falls on trough, that is constructive interference. Amplitudes are added, intensity is more, it is bright. So if a crest and a trough cross, then amplitudes cancel, intensity becomes minimum, that is a destructive part. So also we have seen Young's double slit experiment, which is clearly explains the phenomena of interference, and we also gone through a derivation, that is theory of interference fringes. We tried to derive an expression for fringe width, that is beta equal to lambda d by d. We started from the same diagram of Young's double slit, that is source S and A and B, two slits, two parts of same source, light waves coming from A is AP, from B is BP, then there is a screen at a distance D, and C is center of screen, which is equal distance from AB. P is any point at which intensity is calculated, which is at a distance x from C. So we find path difference between AP and BP by Pythagoras theorem. bp square minus ap square is equal to d square plus x plus d by 2 square minus d square plus x minus d by 2 square. And so we obtain path difference bp minus ap is equal to 2xd by 2d, that is xd by d. And by putting the condition for bright fringe, if it is n lambda, then it is bright. If it is 2n plus 1 lambda by 2, it is dark. Ultimately, fringe width expression is beta is equal to lambda by d. So we see that fringe width, that is separation between two consecutive bright fringes or two consecutive dark fringes, is same, and it is directly proportional to lambda. If lambda increases, fringe width increases. If d, that is separation between source and screen, increases, beta increases, and it is inversely proportional to d, small d, that is distance between two sources.